So for day 3, we have lesson 2.4, which is the sine and cosine ratio. This is really similar to our first lesson, except now we're just using a different button in our calculator for different ratios. So remember, tangent was when we had our opposite and our adjacent only. The sine and cosine will take care of other ones when the angles are not given that are maybe the adjacent side and the opposite, okay? So the railroad track through the mountains between Field BC and Hector BC includes spiral tunnels. They are built in the 1900s to reduce the angle of inclination of the track between the two towns. They want us to find out this angle right here, which is kind of shown with that little marker. They're giving us two pieces here. So we want to label it. We have our hypotenuse and we have our adjacent is always the two side lengths coming out of the angle you're looking from, which means that this is your opposite side length. Now, what's important to notice is that we're not given the adjacent side and we're not given an angle. So the only way to be able to use tan is if we do Pythagorean theorem first, which kind of takes away from some time here that we have. So we're going to fill in our hypotenuse into always your C spot, which is 6.6 squared. So it's always going to be C squared is your longest side, so 6.6. And your 297, what you'll notice is that the issue is that they're not all in kilometers. The 297 is in meters, which is not consistent. So we have to be consistent if we want to do this properly. So what you can do is take this number and divide it by 1,000, and that will convert it to kilometers for you. So in your calculator, whenever you have meters and you're trying to go to kilometers, divide by 1,000. 297 divided by 1,000 gives me 0.297. So some of you will have to put that S to D button. Remember, the S to D changes it from a fraction to a decimal. So S to D, 0.297. Now we can use that number because if it's not consistent, if they're not both in kilometers, then our answer is not going to make sense later on. So we can fill that into either A or B. It doesn't really matter. I'll fill it into B. So 0.297 squared. Then I'll calculate what each of those are. So in your calculator, you're putting 0.297 squared. And I get that it is 0.088209. And then I'll do 6.6 squared. 43.56. In order to get a squared by itself, you have to actually do the opposite of that positive 0.088209, which is subtracting. So you have to subtract both sides by this really small number. And that's the only way that you're going to get those two guys by themselves, right? You're going to get the a's by itself. So that means a squared equals, you're going to put 43.56 minus 0.088209 in your calculator. So this is what I get when I subtract those two numbers. I'll just keep two decimal places. Lastly, we have to square root both sides to get a by itself. So the square root of that number should be about 6.59. And that's in kilometers. So that makes sense, 6.59, which is smaller than 6.6. So it's very slightly smaller. It's not much of a difference, but as long as it's smaller than your hypotenuse, it's still good. Once we have that, now we're going to go to the tan ratio. Tan of our angle, which we don't know, is equal to our opposite side, which we do know is 0.297, divided by the side we just found, which was our adjacent, 6.59. And what you need to still remember is that anytime you want to find an angle, you have to bring the tan to the other side, and it always becomes tan inverse when you bring it over. Okay, Okay, so in your calculator, you're actually doing tan inverse of the 0.297 and then dividing it by 6.59. Okay, so we're going to see what the angle is. It's going to be really small. So step 1, go shift tan, so tan inverse or second tan. To get tan inverse, make sure that you are in degree mode. And then you're going to put the opposite divided by your adjacent. Close your bracket. You should get 2.59, and this is an angle in degrees, a really small angle in degrees, 2.58 degrees. So theta equals 2.58 degrees, and that's the angle of inclination, so it's a really small angle. Okay, so that's our first kind of thing, but as you can see, it was a lot of work. This first one was a lot of work because we didn't have the adjacent side, and when we don't have that, we have to do a lot more work. So I'm going to show you how to save time with this lesson. So just to show you that ratios, as you are looking at a similar triangle, if the angles are the same and the side lengths are different, these are called similar triangles. So let's look at the first triangle, which is this one right here, this one in yellow. Our hypotenuse for that one is 5, and our opposite side is 3, and our adjacent side is 4. Because remember, if you're looking from angle A, this is your adjacent at the bottom, the opposite, opposite, and your hypotenuse is the longest side. And then your side opposite over hypotenuse, opposite is over hypotenuse is 3 over 5, and your side adjacent to your angle divided by your hypotenuse is 4 out of 5. Let's look at the next triangle. The next triangle would be looking at this one right here. They're saying you're looking from A, D, E. So this is the triangle that you're looking at now. The hypotenuse would be 5 and 5, which is 10. The opposite side is that 6. This is the opposite side. It's 6. And the adjacent side would have been 8 because it's double that bottom one. So it's 4 and 4, which is 8. So that means your opposite side over your hypotenuse is 6 over 10, which simplifies to 3 over 5. Do you guys see how the ratio is the same? So 3 over 5, and then 8 over 10 simplifies to 4 out of 5. So as you can see, it's the same answer as above for your ratios. Now let's look at the next one. So now we're looking at this triangle right here. Your hypotenuse is 15 because it's 5, 5, and 5. Your opposite side is 9 from angle A. And then your bottom, if you have the 4, 4, and 4 added together, you get 12. So as you can see, the opposite side is 9 over your hypotenuse is 15. And you can simplify that by dividing the top and bottom by 3, which is actually 3 over 5 as well. And then our adjacent over our hypotenuse is 12 over 15, which simplifies to the top can be divided by 3, and the bottom can be divided by 3, which is 4 out of 5. So same as the top ones. And our last one is looking at the biggest triangle that we can create, which is this one here. So the big, big, big triangle. Your hypotenuse is now 20. Your opposite side is 12, and your adjacent side is 16. So that means 12 out of 20. We can divide the top and bottom by, let's see, 6. Yeah, so we can actually, I would divide by 4. Divide by 4. So if you divide the top by 4, you get 3, and if you divide 20 by 4, you get 5. So it's the same as the previous answers. And then 16 over 20 divide by 4, which is 4 out of 5. So no matter what, if you're looking at a similar triangle, no matter what sides you look at, if they're a similar triangle, they're always going to give you the same ratios. So this is the same, and this is the same. So that's why we can create a rule where we have the sine ratio we're going to use something called SO. The sine ratio is always equal to our opposite side divided by our hypotenuse side. And our cos theta is always equal to, we use ca. So we'll have so, ca, and then our last one, toa, which we previously learned, helps us remember this, is our adjacent side divided by our hypotenuse side. So remember, so, ka, toa, so, ka, toa, so, ka, toa. Remember that. So sine is always the opposite hypotenuse. Cos is always the adjacent divided by the hypotenuse. Tan is always the opposite over adjacent. So if you remember those, so, ka, toa, it will help you remember these equations here. So in example number 1, they're giving you triangle GHJ. GHJ. Identify the side opposite to angle G. So let's look at angle G. What's the opposite to it and what's the adjacent to it? Well, I always start by labeling the hypotenuse, and then that means that the other leg coming out of that same angle is your adjacent. And this means that this is the opposite to angle G. So we've just identified the sides. That's step 1. So for A. Now they want us to figure out the ratios for sine of G. Sine of G, we always have to write so. Remember, so. That means you have to do opposite over hypotenuse. Our opposite side to G is going to be 8. We already labeled that. And our hypotenuse we labeled with a 17. So that's our answer. So that's our ratio, 8 over 17. But they want us to round to the nearest hundredth, which means divide those numbers and round to 2 decimal places. Hundredth means 2 decimal places. So 8 divided by 17 is 0.47. And then we have cos of G. So since we're still looking from angle G, we still want to keep the side lengths labeled the exact same way. But now we're going to use ca. Ca is adjacent over your hypotenuse. Your adjacent side is 15, and your hypotenuse will be replaced with a 17. So we could leave it as a fraction, but they do tell us they want it to the nearest hundredth, means divide those two numbers and write it as a decimal to 2 decimal places. 15 divided by 17. So I'm going to write 0.88 because the number after it is a 2, so that means you don't change the numbers before it. So 0.88. So those are your sine and cos ratios. They're either written as a fraction or a decimal number. So what we want to remember from our previous lessons is that anytime you want to find the measure of an angle, you're going to use that sine inverse or cos inverse button. Okay, so always use sine inverse or cos inverse to find missing angles. So now that's what they want us to do. They want us to find a missing angle. The cool thing is that once we find one angle, we can always find the remaining one. So that square is always 90, but we never use that to calculate SOHCAHTOA, right? So let's look at angle K. So let's look at angle K, which is the first one that they're kind of giving us. Angle K, right here. We need to label our triangle based on angle K. So our longest side is always our hypotenuse. The other leg coming out of it is always called your adjacent. And then this is your opposite side, which is that kind of remaining side. So start by labeling it. Now you have to see what you have. So we need to pick what's the best from SOHCAHTOA. So as you can see, I have a number for my opposite and I have a number for my hypotenuse, but I have no number here for adjacent. So I don't want to use anything that has adjacent. So I don't want to use anything that has an A in it. So those are gone because I don't have a number for adjacent. So why use an equation where you don't have a piece for it? So that's why in order to find my missing angle, I have to use opposite over hypotenuse, which leaves me with sine. So you're going to write sine of my angle K is equal to your opposite side over your hypotenuse. So it's all about picking the right ratio to make your life and your work less. Okay, so this will make your life easier. K we don't know, but we do know our opposite side is 3 and our hypotenuse is 8. So I mentioned above and in previous lessons that anytime you want to find an angle, you have to bring the ratio over to the other side and do inverse. So you're going to have to do sine inverse of 3 over 8. So I just brought that sine to the other side and it just becomes a sine inverse in front of your answer that you have on the right side. Whatever it is, if it's a decimal, if it's a fraction, it doesn't matter as long as you do sine inverse of it. And this is where you switch to your calculator. Make sure that you're in the right mode. You need to be in degree mode in your calculator. That trick to check is if you do tan 45. I'm going to keep reminding you of this because you want to check daily and make sure that you're always in the same mode. So tan 45 is 1, you're good. Okay, so if tan 45 is 1, you're in the right mode. So we're going to have to do sine inverse of 3 over 8. So you're going to have to do second or shift sine. Second or shift sine. And then you're going to go 3 divided by 8 in brackets. 3 divided by 8, close your brackets. This is what you get. You get an angle of 22 degrees. So these are angles that we just found because we're doing the inverse button. So anytime you do inverse, you get a degree. So we get 22 degrees. But they do want the answer to the nearest tenth of a degree, which means that I do have to look and put that 0 in there. So 22.0 because the 2 doesn't change it. So I'm going to adjust that, put 0.0 degrees. That's how you write to the nearest tenth if you don't have anything after it, really. So now I know what K is. K, this angle right here, is 22.0. And anytime you have two angles, you can always find the third, which is angle M, by using the 180 rule. All angles on a triangle should always add up to 180 degrees. So subtract from 180, 90, and in this case, 22.0 degrees to find your missing angle. So in your calculator, you are taking 180, subtract 90, which is that square, minus 22, which is what you just found. And you should get that it's 68.0 degrees because it's 68. So you have to add that 0.0 to show to the nearest tenth. See, tenth right there. Make sure you have one number after the decimal, even if there is no number really listed. So those are your two answers. They want us to find angle K and M. So we're done. Good. So step one. Whatever side length or whatever angle you start with, label your sides. Once you figure out what ratio you use, you're just plugging in the numbers and solving for your angle by doing the inverse. In this case, sine inverse. And once I find one angle, and I have two angles in total, I have to find the third by doing the 180 rule. 180 minus the other two gives me the missing angle. So angle of elevation. It's always when pretty much that you're looking from eye level and up. So angle of elevation is if you were to look straight and then up from there, that would be the angle that's created to that horizontal. So it can be from the ground as well, an angle of elevation. So you should be going always up. If it's an angle of elevation versus an angle of depression is from horizontal, you're going downwards. Okay. Example number 3. An observer is sitting on a dock watching a float plane in Vancouver Harbor. At a certain time, the plane is 300 meters above the water and 430 meters from the observer. Determine the angle of elevation of the plane measured from the observer. So there's the observer. There's his eye level. You see there's the horizontal, and then he sees the plane. Looks like a fish, but there's my plane. It's really small looking. So we know that the plane is 300 meters above the water. So I guess we're looking from the water. So we're going to look from his legs then, I guess. It's not from his eye level. So here is the water. So the plane is 300 meters above the water and 430 meters from the observer. Determine the angle of elevation of the plane measured from the observer. Right there. Okay, so the hard part was kind of drawing it and making sure that the information makes sense. So we know that we're looking at the plane. The plane is above water. We know the distance of the plane above the water, and we know how far it is from the observer. So if there's the person, it's that hypotenuse value that we just found. Okay, so when we label our triangle, this longest side is our hypotenuse. So remember, that's one side. The other side, the other length coming out of the angle is always called your adjacent, which means that this has to be your opposite. So again, we have to look for something that has O and H, right? Because we have an H for hypotenuse and we have O for opposite. Those are the side lengths that we have. So we know it's SOHCAHTOA. So we have to use SO. Again, we're going to use that sine ratio. Sine of our angle equals our opposite over our hypotenuse. So I always start with that formula. We don't know the angle, so we're going to leave it as it is, but we do know the opposite is 300 and our hypotenuse is 430. To find the angle, we always have to bring that sine to the other side by doing sine inverse. So anytime you shift and isolate for an angle, you're going to do the sine inverse or cos inverse or tan inverse. It really doesn't matter. So in your calculator, you're doing sine inverse of 300 divided by 430. Okay, so sine inverse of 300 divided by 430 is 44.2. 44.2. And that's degrees. It does say to the nearest degree, so make sure you look at the rounding and make sure that your number makes sense. Nearest degree means nearest whole number, so I would round down to 44 degrees, because 0.2 means that you keep the whole number the same. You don't round it to 45. So we just found the angle of elevation from the observer. Okay, so make sure you use the right ratio. What happens to cos A as the angle gets closer to theta? What happens to cos A? So let's look at what the ratio is equal to. If I start off with like a bigger number, let's try cos of let's try 80, and then we'll go down from there. So cos of 80, you have to bring in degree mode to do this. You'll get 0.1736. Then I'll go down from there. Let's go down to 60 degrees. Cos of 60. I'm just seeing what happens as you go closer to 0. 0.5. Then I can do cos of 30 degrees. I'm just seeing what the trend is. What's happening to it? I get 0.866 and cos of, let's say, 0 degrees. Cos of 0 equals 1. So as you can see, the ratio got bigger and it got to 1. So ratio increased until it reached 1. So as I made the angle smaller, it actually increased your value to 1. So what, and now they're doing, let's do the same thing for sine now. Sine of 80, let's see what happens there. So sine of 80 in my calculator is 0.985. So it's starting big, and then I'm going to do sine of 60. I get 0.866, and then we have sine of 30. You'll see that the numbers kind of swap from cos, 0.5, and then sine of 0 is 0. So you will see that the ratio actually decreases. Until it got to 0. So for cos, the number is going to increase as your angle goes down, versus for sine is going to, as your angle goes down, you're going to decrease your value. Okay. So how are cos G and sine H related? So if we look at our, if we look at a triangle, here's G, here's H. Let's say this is E, okay? There's our right angle. I'm going to put some numbers in just to show you how they could relate to each other. So this is 2, 5, and 3, for example. So if we're looking from cos G is looking from this angle. That's where you have to use ca. So remember ca, adjacent over hypotenuse. So I'm going to label my triangle. If I'm labeling my triangle from G, then this is my hypotenuse, always the longest side. The other leg coming out of it is always your adjacent, and this is your opposite. So ca is equal to your adjacent, which is 2, over your hypotenuse is 5. Now let's relabel it. What if we did sine of H? So we're looking from now H, so I have to relabel my triangle. So if we're looking from, I'm going to fix that, take this off, this is G. Okay, now we're looking from H. If we're looking from H, this is still our hypotenuse, but this side is our adjacent side, because it's the other leg coming out of H. And this is your opposite. So in this case, if we're looking at sine, sine is always opposite, which is 2 over our hypotenuse is 5. And that's our so, opposite over hypotenuse. So as you can see, they're actually equal to each other. So this relationship occurs because they're using their other ratios, right? If you look from a different angle, they're going to use each other's values. So they're going to be equal to each other in this case. Now, if we are looking at both from G, they would have different answers, right? So it all depends on what angle you're looking from. Okay, so let's look at this one. Let's see what ratio we would use if we were trying to solve for these. And I'm going to solve for the one for a cos just to practice because we haven't done a cos one yet. Okay, so if we're looking at question A, they're asking us to do A, look from A and label our sides. So we know this is our hypotenuse, this is our adjacent, this is our opposite side. So we have for angle A, for A, we have opposite and adjacent, which means that we have to have TOA. Opposite and adjacent is when you use tan. Tan of A would equal our opposite side is 6 over our adjacent side is 4. So we would use that to solve for the angle A. Let's go on to B. B, let's see, we want to solve for M right there, M. So we're given this angle, so we have to look from the angle given. So that means we're looking from 43, which means that this is your hypotenuse. It's always opposite to your 90-degree angle. This has to be your adjacent if we labeled it, and this is your opposite. So we need to have M in there. So we need to have an O, and we have to have our adjacent side, which is A, which means that it's tan again. So tan of 43 degrees equals our opposite is M over our adjacent is 8, and then we would solve for M. And this one here we're actually going to solve for because this is using tan of B, okay, or a value of B. So let's look at this one. We're looking at B and we're saying this is our hypotenuse, which means that this has to be our adjacent and this is our opposite, right? So remember, from your angle B, one side should always be opposite coming out of B, and one side, one of the legs attached to B should always be your adjacent. So that's how I figured that out. Now we need to use a ratio that has A and H. So that has to be cos. So cos of our angle B equals our adjacent side, 5, divided by our hypotenuse, which is 24. So in order to find B, just like in our cos kind of ratios, we have to bring this cos to the other side and move it over. Anytime you bring it across the equal sign, it's going to become inverse. So you're going to do cos inverse of 5 over 24, just like we did for the sine ratio. And then we put it in our calculator exactly how you see it. So cos inverse of 5 divided by 24. So you're going to do shift cos, or second cos. 5 divided by 24, close your brackets. So 5 divided by 24, you get 77.97. You can keep it like that. If they said to the nearest tenth, you would actually have to round to 78.0, 70, because the next number after 77 is 78.0, because this would be like, think of it like 779. The next number would be 780, right? So that's how I had to round to 1 decimal place. If they wanted the answer to the nearest hundredth, that's what that one is. Or if they said to the nearest whole number, it would just be 78. So it really depends on what they want you to round to. Good. So that is our day 3. So if you guys go up, you'll notice that there's homework assigned for this one. So day 3, it's really important to practice these ones. We're gonna have a quiz tomorrow. So make sure you practice for lesson 2.4. Page 95 to 96, 5B, 6B, 7B, 8B, 9B, 12, and 14. Okay, and then ask me questions if you have any concerns or you're not sure how to use your calculators. Okay, so